All right, this is the Algebra 2 Unit 6 Lesson 7 video over inverses of polynomial functions. So inverses are a concept that is first kind of introduced previously in the course, but we're going to kind of do a quick overview of that since we're starting from the second half here. But in general, the inverse of a function is when we take all of the x values and switch them with the y values. So let me actually close that. It's not R1 drawing. All right. So basically inverses are found by basically switching the x values and the y values of a function. And it's a way of looking at what the function is that is the exact opposite of whatever our current function is. So first I want to look at what this looks like graphically, and then we'll talk about what it looks like algebraically. So I'm just going to graph two functions that I know are inverses of each other. And that's going to be y equals 3x minus 2 and y equals parentheses x plus 2 divided by 3. So these two functions are inverses of one another. I know that I looked it up earlier. I planned this, obviously. So these are inverses of each other. So let me just kind of get myself out of the way here, close this down, and look at this. So if we look at this, we see they have an intersection point. But what we need to know more than anything is that if I were to graph a third line, and that line would be y equals x, the green line cuts exactly through the middle of in between those two lines, the red line and the blue line, and the green line is crossing right in between them, forming a sort of mirror image between either side of the green line. And that should make sense to us because if we say y equals x, and we just switch the x and the y values, if I pick 2 points, if I pick that point there, negative 2, 0 on the blue line, then I should have the opposite point on the other line, which would be 0, negative 2. So let's go look. And sure enough, there's 0, negative 2. I could do the same thing here. What if I looked at these 2 points? Oh, look, those 2 points are also exact opposite points, 0.667 and 0.6670. So what we found is that each line has all of the opposite xy points switched from the original, which should make sense to us considering we just said that inverses are functions where the x values and the y values have been switched. All right, so that's kind of a graphical understanding of how this works. Let's hop over to the lesson and let's talk about how we do this algebraically. So first things first, you got some vocabulary here. All of this content, questions 1, 2, and 3, you can find them in the vocab or in the lesson, in particular the vertical and horizontal line tests, which I will discuss here later. Number 4. Determine the inverse of the function by interchanging the variables and solving for y in terms of x. So to find the inverse of a function, we have the function y equals 2x plus 3. Let me write that down. Y equals 2x plus 3. We are going to do what we said right here. We are going to switch the x and the y. So I'm going to have a new function, x equals 2y plus 3. But that's not the end of the process. But that is step 1. Switch x and y. The next step, and kind of the last step, is to solve for y again. It already was y equals when we started, but we've switched the x and the y, and now we want it to be y equals again. So we're going to go through just basic algebra process. I want y by itself. So how do I do that? Well, I need to get rid of this 3, so let's subtract 3 from both sides. And I get x minus 3 equals 2y. I have 2 times y, so I'm going to divide by 2. And I get y equals x minus 3 over 2. So that is the inverse, because I've switched the x and the y and found a new function. Another way of writing that would be 1/2 x minus 3 over 2, if I just break this fraction up, equals y. So both of those are the same expression. And we see that we have that answer, 1/2 x minus 3 over 2, right here. Now, what if I wasn't sure and I wanted to make sure? Well, I can just go back to my graph and I can type in y equals 2x plus 3 and then get my answer, 1/2 x minus 3 over 2, y equals, parentheses 1, or I don't need parentheses, equals 1/2 x minus 3 divided by 2. Okay, let me drag myself over here. Let's see with these. Okay, now you should see, and we can confirm by graphing the line y equals x, that those are inverses of each other because they are opposite. If I highlight all the same kind of points that I highlighted before, you can see they are the switched versions of each other when I graph this line y equals x, which is kind of the key concept there for the visual aid. So more of the same in number 5. You need to switch the y and the x and then solve again for y using algebra. Same with number 6. Switch the y and the x, solve again. Let's look at this one, or let's look at a similar example. What if I had the function y equals 5x squared plus 1? Again, I'm going to first switch the x and the y, giving me x equals 5y squared plus 1. Next step, solve for y again. Subtract 1, x minus 1 equals 5y squared. I see there's a 5 there, so let's keep going. We're going to divide both sides by 5. I get x minus 1 over 5 equals y squared. I still need to get y by itself. The last step is going to be to undo the squared by taking the square root, giving me y equals the square root of x minus 1 over 5, which is a lot, but nothing in there is too crazy. We're just step by step undoing everything that is in that first original equation. And when we undo it all, we get this. That's going to be very similar to what you have in number 6, number 7. Okay, so you're going to be dealing with some square roots there. Remember, you can always graph the two along with the line y equals x to confirm that you got the correct answer. But again, the basic steps are switch the x and the y, and then solve for y again. All right. Then we have a couple of questions here about the horizontal or vertical line test. And this is what you need to know. If you have a function and you want to know if the inverse is a function, you are going to run the horizontal line test. Okay, I'm going to scroll to the top so you can read that definition. Horizontal line test. If every horizontal line intersects a graph just once, then the function is a one-to-one function, and therefore the inverse exists. So when they ask us, is the inverse of a function, of this function, a function? We need to do the horizontal line test and see, does any horizontal line touch twice? And yes, many do. All of these touch twice. That means no. Whereas in this one, all these horizontal lines touch just once. Therefore, the answer is yes. All right. Then we get to our review questions. And this is reaching back into the first half of the course. And what you really need to know about this is that you are going to take these expressions and you are going to plug them into this expression. So for instance, if they gave me the following, and we'll talk through these problems. These are review problems from the first half of Algebra 2. But really all you're going to be doing is you're going to be substituting these expressions for x and y in the second part. So for instance, with this one, they want us to do y minus x. And they tell us that y equals negative 2i. Negative 2 plus 7i. Sorry about that. Plus 7i. And x equals 3 plus 5i. If you remember, I is just an expression we use for the square root of negative 1. So these were problems in that unit where we've been working with this type of expression. So just to be clear, you're going to take this and you're going to put it in for the y. So it's going to be negative 2 plus 7i minus, and then in parentheses, we're going to put the expression for the x, which is this. 3 plus 5i. So then it's going to be negative 2 plus 7i minus 3 minus 5i, because this negative gets distributed. And then we just combine like terms. So the negative 2 and the negative 3 go together to make negative 5. And then the 7i minus 5i, 7 minus 5 is 2i. And so that would be the final answer. And I think that is one of our answer choices. Negative 5 plus 2i. So there you go. Same thing in number 11. I'll let you do that one on your own though. And that's the end of this lesson.